plate tectonics. Let's move on. So, what is plate tectonics based on? Well, it's built on the foundation of that famous scientist, one of my favorites, Alfred Wegener's continental drift. Remember, we talked about those 5 pieces of evidence. Those are kind of going to get tied into this as well, but we're going to get into more depth of how those plate tectonics work together. So this is when the Earth's surface is divided up into those distinct plates that move around relative to one another on that semi-liquid asthenosphere. Remember, that's that peanut buttery consistency asthenosphere that the plates kind of float around on top of. And it's driven by those giant convection currents going on in the asthenosphere. Because remember, it warms up and then it cools down. And then it warms up and then it'll cool down. And it causes the plates to be able to move. Okay? How many plates are there? There's 14 major plates. But then there's a whole bunch of little itty bitty ones too that kind of happen in different areas. How fast do they move? They can move about 1/2 inch to about 4 inches per year, depending on what direction they're going in, how fast they're already moving, whole bunch of stuff. So what happens at these plate boundaries? You can have volcanoes creating new rock. You can have earthquakes because you have the plates shifting and they're rubbing up against each other and jolting quickly, creating earthquakes. You also can have the plates coming together and creating mountains. So what is the plate boundary? Well, it's where you have 2 plates that kind of meet together. In this case, you have a continental plate boundary versus an oceanic plate boundary, that's where they're meeting together, okay? Because remember, we have 2 different types of plates. You have 2 different types of crust. Continental crust, it's thicker and granitic, and then you have the oceanic crust. It's thinner, and it's usually basaltic, made of basalts. Okay, thicker and less dense and made of granite. Thinner, more dense, basaltic. Don't forget that. So first you have your divergent plate boundaries. Divergent means that it's going to be pulling apart from each other. They're going to be dividing, divergent. Okay, so plates are moving apart. This is where you get mid-ocean ridges or the mid-Atlantic ridge. And this is where you're going to have earthquakes happening as well. You also have them not in the ocean too. Those are called rift valleys then. So there's the East African Rift Valley. That's on the side of the African continent. This is where the age of the rocks near the ridge, at the ridge right here where it's pulling apart. The rocks in the middle here are going to be the youngest. As it gets farther away, those rocks are going to get older. Okay, we talked about that in the last part of this unit. So this is the East African Rift. It's pulling apart. Actually, recently, in the past couple of years, there have been significant shiftings and changings in the East African Rift that some of these areas have gotten wider, and it's kind of scary. But most of these ridges actually happen in the oceans. This one happens to be on land, but most of the ridges are in the oceans. Now, convergent plate boundaries is where you have 2 plate boundaries that are coming together and they crash into each other different ways, okay? So this is where plates are coming together, so it creates trenches, mountains, volcanoes, and you have the 3 types. You have continental crust. That's where you have a continental crust, and they crash into each other, and actually both of them will rise up. And this will create earthquakes, and it will create mountains. Okay, it results in mountains and earthquakes. So the Himalayan mountains, that's how these were created. All right, India, are the Himalayan mountains in India, and the Appalachians in North America were created like this. So this is continental, whoop, earthquakes and mountains. And here's some beautiful pictures of mountains. Now we have oceanic. Let's do blue as oceanic, and this will be continental, okay? So the subduction boundary is the denser oceanic gets subducted under the less dense continental crust. So this results in trenches, volcanoes, and deep earthquakes. So like Mount St. Helens in Washington State, that was created by this type of plate boundary. So then the subducting plate melts and provides the magma for the volcano, and then you have volcanic arcs, series of volcanoes that come near the subduction zone. So where this happens and how this happens, ready? Continental crust, we'll say that this one's oceanic crust. This is more dense and thinner, less dense and thicker. These two are coming together. This oceanic crust is going to push itself underneath here, and this one's going to start to rise up, okay? This area where I'm pointing to with my nose, that is going to be a trench. This deep part right here is creating a trench. Under here in this area, because this is being melted down here, this subducted piece, it is going to create volcanoes or volcanic activity under here, along with creating mountains, okay? So you have, I'm gonna hold on to it like this. Oceanic is being subducted. This part is the subduction zone. This area right here is a trench. You can have volcanoes coming up through here, and this oceanic crust is just going to keep pushing itself underneath. This area can get deeper and deeper and deeper and deeper. In fact, this is how the Mariana Trench, one of the deepest parts of the ocean, that's how that was created. There's something else. So you can see this oceanic crust, which is more dense, it's thinner and more dense, it's getting forced under this continental crust right here, and that continental crust is less dense, it's much thicker, and you can see that there's actually volcanoes going up through here, and there's a mountainous region. That's because this is kind of forcing it upwards. And where that's pretty famous is where on South America, you have the plate coming in here, and these are actually all the Andes mountains in here. This is known as, if you look on page, which I'm gonna do another video to show you this up close. If you look on page 5 of your reference tables, you can see the South American plate. This is the Nazca plate that's kind of crashing into the South American plate. This is the Peru-Chile Trench. So in fact, it's really deep water running up along against the coast of the South America, okay? So these are the Andes Mountains in South America. Some of the best skiing in the world happens around in this area. And then we have oceanic. So I'm gonna take, imagine this one's blue, okay? You have oceanic crust and oceanic crust coming together. So the subduction boundary, the denser of the two crusts, so again, you're starting with two actually dense crusts. The denser of the two, say this blue one's gonna be the denser of the two, subducts under the lesser one. This also results in trenches. So this one's going to push itself under this one and keep going. You're gonna create the trench here, and this is still gonna keep growing and growing, and it creates underwater sea mountains, which eventually sometimes these mountains get to be so tall that they create islands after a while. That's how the Aleutian Islands off of the coast of Alaska, that like tail off of Alaska to the west of it, those are the Aleutian Islands. Okay, so the Hunga Tonga Trench actually creates lots of different mountains in there, but again, it's the two oceanic crusts. They react similar to the oceanic continental, but they're both underwater. So this is off the coast of Alaska. This is what I was telling you about. These Aleutian Islands are all created by a volcanic arc. And then you have transform plate boundaries. Transform plate boundaries is where you have two plate boundaries that are sliding against one another, okay? So it says it's also known as a lateral fault. Plates are sliding past each other. This results in great amounts of tension. It results in faults and earthquakes. So what happens is you can actually do it with your hands. If you take your hands and you push them together pretty hard, and then you try to move one forward and one backwards, you're gonna notice that it's gonna jut pretty quickly. When it juts pretty quickly, that's kind of like an earthquake. that's what happens with an earthquake, is that when it juts, it's going to cause those vibrations to travel through the earth, and it creates a pretty big earthquake. So this is like the San Andreas Fault in California. So these are those transform plate boundaries. They slide past one another. So this chart is in your reference tables. I'm going to make another video that's going to be pretty up close and personal, and I'm going to draw all over it and show you different things on it. But this is what's on page 5 of your reference table that you need to become familiar with, because you are going to have a lab on it. Okay, but let me break it down just a little bit right for you now. You have divergent plate boundaries, which are pulling away from each other. The arrows are all going in opposite directions. Then you have convergent, where it's coming together, and you're going to have the arrows coming together in most places right here. And then you have transform, which is sliding past each other. You've got like the San Andreas Fault. Right out here in the middle of the Antarctic Ocean, you've got a transform plate boundary going on. And then you have the dotted lines, which is complex or uncertain. It's kind of like sometimes it's transformed, sometimes it's divergent, sometimes it's convergent. It all depends on what is moving around it for it to happen. So these convection cells, the differences in density down in that asthenosphere is what's causing and driving all of this stuff to move. The hot interior of the earth dissipates the heat towards the surface. Okay, so here's those convection currents, and it's moving the oceanic crusts away from each other. So what is a hot spot? Well, a hot spot is actually where the magma rises up from the Earth's interior, and it actually breaks through the crust, okay? So what happens is the Hawaiian Islands, the Pacific plate is moving over a hot spot. So a chain of active volcano islands is what's being created. So say that my fist is a hot spot, and the plate is sitting on top of the hot spot. And as my hot spot starts to create more island and volcanic activity, the plate is actually moving on top of the hot spot, which is why Hawaii has a series of islands that kind of trail off, the smallest being farther away and the largest being where the hot spot actually is. So you can see the island of Hawaii is the largest, and that's because it's right over the top of the hot spot. Kilauea, which is one of the famous active volcanoes on the island of Hawaii, it's got new rock coming up through and creating new parts of the island. Whereas Molokai, Oahu, and Kauai is the oldest out of all of them because it is the farthest away from the hot spot, because this plate is moving in this direction away from the hot spot. Okay, so the island of Hawaii actually eventually millions of years from now will be several miles away, and there's going to be probably a larger, bigger island than Hawaii, and we're just going to have to name a new island part of the state of Hawaii. Okay? Plate tectonics. Good stuff.